Very good afternoon. So today we discuss about the block 3 relational database management system unit 9 DBMS implementation and future trend. The main objective of this unit is, after studying this unit, a student can learn how to interface with the web database, explain relational database language, understand how to manage a database using a cloud-based solution, know how to control database access. So these are the main objectives a student can learn after this unit. Then we discuss about the introduction. So DBMS is a software which acts as an interface between the user and the database. So with the advent of cloud computing, the market for database management system has shifted towards cloud-based solution. In the earlier days, what happened? Every organization stored their data and information in their database. And database is centralized and kept in one place, and number of computers of different departments are connected with the server to access the common database. But nowadays, it is needed the cloud-based DBMS. Hence, cloud-based DBMS solutions offer many advantages over on-premise solutions, such as scalability, flexibility, and reduced infrastructure cost. Cloud-based solutions also offer the ability to easily integrate with other cloud-based services, such as analytics and machine learning tools, which can help organizations gain insights from their data more quickly and efficiently. Another advantages of the cloud-based DBMS solution is that they often come with built-in security features, such as encryption and multi-factor authentication, which can help to protect sensitive data. This is specifically important in today's world, where data breaches and cyber attacks are becoming increasingly common. So what happened? The cloud-based DBMS means everyone can access the database at the remote place also. Hence, the security is the major component. How to protect the important information, important data in the database means only the authentic person can access. So there are so many security mechanisms. How to encrypt, how to decrypt the sensitive data so that data cannot be hacked by any person. Practically all use of database occurs from within application programs. Corresponding almost all users interact with the database is indirect by an application program. Not surprisingly, therefore, database systems have long support tools such as form and GUI builders, which help in rapid development of applications that interface with users. In recent years, the web has become the most widely used user interface to database. Then we discuss about web interface to database. What is the web interface to database? The web has become important as a front end to database from several reasons. Web browsers provides a facility to all the endeavors to interact with the database. Database is the backend. It is located anywhere in the world. Through the application or web browser, we can connect with the database backend. So web browser provides the facility to the end users to access the backend for their purpose. The front end can run on any computer system, and there is no need for a user to download any special purpose software to access information. Further, today almost everyone can afford it has access to web. With the growth of information service and electronic commerce on the web, database used for information services, decision support, and transaction processing must be linked with the web. As we know that e-commerce is a platform to sell or buy the products. So there are different types of e-commerce. One is your B2B, business to business, then B2C, business to customer, C2B, customer to business, C2C, customer to customer, G2B, government to business, G2C, government to customer. In this way, there are different types of electronic commerce. And all the electronic commerce are based on the web database. The web application provides the facility to the users to interact with the web database developed by the companies. Web interface to database allow user to interact with and manipulate data stored in a database through a web browser. These interfaces can be custom built or implemented using off-the-shelf software. They provide a user-friendly way for non-technical users to access and use data. Some common type of web interface to database include web forms, reporting interface, dashboard interface, and mobile interface. What is that waveform? Waveforms allows user to input data into a database through a web browser. They can be used for tasks such as data entry, surveys, or online order. Similarly, reporting interface allow users to query and retrieve data from a database and display the results in a user-friendly format such as chart, graph, or tables. We store our data in the database, and as and when it is required for any analytical purpose, we can retrieve from the database an analysis and represent to the public with the help of a reporting interface. Then Dashboard interface provides an overview of data in a database, often using visualization such as charts and graphs to display key metrics and trend. Similarly, mobile interface. Mobile interface provides access to a database through a mobile device such as smartphone or tablet. They can be designed to be responsive and mobile friendly, making it easy for user to access data on the go. So for real-time basis, mobile interface is very essential to the end users to access the database. So this is now your web interface to database. Then specialty database. Specialty database are database that are designed to handle specific type of data or specialized applications. And some common examples are GIS. What is actually GIS? GIS is the Geographic Information System. These databases are designed to store and retrieve and analyze special data such as maps and satellite images. Nowadays, we are use this GIS database to know a particular location through the satellite images. So the end user can interact with the GIS system. Similarly, time series database. These databases are optimized for sorting and querying time series data such as stock price, weather data, sensor data through online. Graph database. These databases are designed to store and query graph structures such as social network and recommendation engine. That is actually your Facebook. The Facebook database capture different types of graphs and many photos, and these are the this is the common platform, and the end users can interact with the graph database. Document-oriented database. These databases are optimized for storing and querying semi-structured and unstructured data, such as text document and multimedia content. In memory database, these databases store data in memory instead of disk, allowing for faster access and processing of data. Then real-time database. These databases are designed to handle high-speed, low latency applications such as financial trading system and gaming platform. So gaming platform provides different types of online games to play for the entertainment, and this is not the real-time database. Then we discuss about automation and database management. Database management means we have to arrange the data in a systematic order so that at the time of requirement we can retrieve it from the database for analysis purpose or for the decision making process. So database automation uses the technology and tools to streamline repetitive and manual database management tasks, improving efficiency, consistency, and reducing errors. It involves automating tasks like provisioning, configuration, backups, performance optimization, and deployment. This frees of database administrator DBA to focus on more strategic projects. So automated of database means we are use the new technology, the tools to streamline the database management system. And it is easy for the database administrator to control the whole system and reducing the errors. The main aspects of database automation. It increased efficiency. Automating routine tasks allow DBS to spend more time on complex issues and strategic initiatives. And it reduces errors. Automated process minimize human error that can occur during the manual database management system. Improved consistency. Automation ensure that tasks are performed consistently and reducing variations and potential inconsistencies. Enhanced scalability. Automated systems can handle increasing data volume and workloads without significant manual intervention. So we can easily increase the data volumes in our database on the runtime also. Faster change implementation. Automation allows for faster and more reliable deployment of change of database. Then we discuss about data processing. Automating tasks like data collection, replication, cleanup, and migration helps ensure data is meaningful, secure, and available. So as we know that data is the important asset for every organization. Whatever data we collect, automating the data collection, replication, cleanup, and migration process, and ensure the data is stored in a secure place. And as and when it is required, it is available. That's why that is known as the data processing. Then the next one is actually provisioning and configuration. Automating the set of database environments for different stages of the software development lifecycle streamlines the process. So SDLC is the software development lifecycle. Software development lifecycle is used to develop a software. And here, automation and database management means it helps the entire process to develop a good software. There are so many steps. SDLC. In SDLC, there are 7 steps: feasibility analysis, requirement analysis, requirement gathering and analysis, then design, then actually development means coding, and then testing, then implementation, and then maintenance. So these are the different phases in SDLC. So first one is your feasibility analysis. The feasibility analysis means we have to prepare a budget for the development of the software which is required to implement in the organization. Then as per the budget, then we check it is organizational feasibility, employee feasibility or not. If it is okay, we go for actually requirement gathering and analysis. So as per our need, we collect the data from different sources. So interview, so primary data collection, questionnaire, we contact with the customers and collect the various data, and then we go for development. So after requirement gathering and analysis, we go for design, and if the design is okay, we write the code to execute the front end graphical user interface, and then we move to the testing. After writing the coding, it is required to test the software. So there are different types of testing process: functional testing and structural testing. And after testing, we go for implementation of the software in the organization. After implementation, the post-implementation is known as the maintenance. So maintenance is very important because if any error is there, if any rectification is required, then you will go in the maintenance phase. As for the guideline of the maintenance phase, we go for the rectification. So these are the different steps to develop a software. Means we develop the front end as well as the back end, and we make a connection between the front end and back end through which the user can interact. Then load balancing. Automation can optimize database performance by automatically balancing the workload across multiple servers. Backup and restoration. Automated backups and restoration process are crucial for disaster recovery and data protection. Then security improvements. Security improvements means unauthorized person never access the database. And the automation can help implement strong authentication and access management process, enhancing database security. So how the security is implemented in our database? That is done through automation process. Then regulatory compliance. Automation helps ensure consistent enforcement of data governance and regulatory requirements. Similarly, audits and reporting. So automation can automate audit process and generate reports, providing valuable insights into database performance and compliance. It is a regular task. So on the basis of the auditing and reporting, it will be done automatically and generate the reports which is required for the organization to check the performance and what are the compliance also reporting. Performance tuning. Automation can help optimize database performance by automating tasks like indexing or partitioning and caching. So these are the automation and database management system. Then we discuss about benefits of database automation system. What are the benefits? The first benefits is it reduces cost. Automation can free up DBA for more valuable tasks, potentially reducing staffing needs and associated cost. In the earlier days, in an organization, there are a number of people working together, and the people are working with the manual system because they are never used the computer and they can keep all the records, all the files manually. But automation helps to store all the information in a common place, that is on the server, so that anyone can access through online as and when it is required. So potentially it will reduce the staff. If you reduce the staff, automatically it will reduce the cost. Improve data quality. Automation can help ensure data accuracy and consistency and leading to improved data quality. So this process ensure the data accuracy and the consistency. Whenever we consider the concept as data quality, means quality data must be there in our database and it remains same before change it. Better decision making process. Automated data management process can provide more accurate and timely data, enabling better decision making. Then we discuss about increasing agility. Automation allows business to adapt more quickly to changing requirements and market conditions. Examples of database automation system. Automated backup restores. Regularly backing off database and automatically restoring them in case of failure. Whenever we implement the database management system in the organization, always we kept in your mind how to back off the database. And it can be done automatically. Automated patching and upgrades. Automatically applying patches and upgrades to database software. Automated performance tuning. Automatically optimizing database performance by adjusting the parameters like indexing and caching. Similarly, automated provisioning and configuration. Automatically setting off new database environments for different purposes. Automated security management. Automatically enforcing security policies and monitoring for security threats. So we have to prepare a guideline, and all the people, all the end users can follow this. Then augmented data management, ADM. Augmented data management leverages artificial intelligence, AI, and machine learning, ML, to enhance an automated data management process. It aims to improve efficiency, accuracy, and productivity by automating tasks, providing intelligent insights, and facilitating more informed decision making. So, what happened? The ADM uses the tool AI and machine learning to enhance the quality of data processing in the automated data management process. It aims to improve the efficiency, accuracy, and productivity by automating the task. Then automation. Automation means the augmented data management automates routine data management tasks like data integration, metadata management, data quality checks, reducing manual efforts and errors. That's the meaning of this data management automation. AI and machine learning. ADM utilizes AI and machine learning algorithms to analyze data patterns and predict outcomes and continuously improve data management process. And data discovery and cataloging. ADM emphasizes the importance of discovering, cataloging, and organizing data assets to ensure that they are easily accessible and understandable. Then intelligence enhancement. ADM aims to enhance human capabilities by automating tasks and providing intelligent insights, allowing user to focus on strategic decision-making process, how it is conducted, how it is implemented. Improve data quality. ADM helps identify and resolve data quality issues, ensuring data is accurate, consistent, and reliable. Enhanced data insights. ADM helps in identify relationship between database, provide actionable insights for organization. Then examples of how ADM can be applied. Data integration, metadata management, data quality check, data governance, master data management. So these are the steps we can follow for the augmented data management, ADM. The first one is data integration, automating the process of combining data from various sources. Metadata management means ensuring metadata is accurate and consistent. Metadata means data about data. Then data quality check, identifying and resolving data query issues. Data governance, implementing policies and procedures for data management. Master data management means create a single source of truth of master data we can consider. Then we discuss about in-memory database. In in-memory database management system, DBMS store data primarily in the computer main memory RAM, offering significantly faster data access and processing compared to traditional disk. Disk-based database. This is achieved by eliminating the need to access slow disk storage for data retrieval, resulting in real-time response times. So what happened? We are store our data in the computer's main memory, that is known as the RAM, which is faster to access by the computer system to process the data, and this is achieved by eliminating the need of access slow disk storage for data retrieval. Data storage. In memory databases, data are stored directly in RAM, the computer's main memory. Speed and performance. RAM offers significantly faster access speeds compared to disk storage, leading to near instantaneous data access and processing. Nowadays, we are used SSD instead of data storage in the earlier days by the hard disk. If you use SSD, it is faster than the hard disk for the storage of data, for the retrieve of data, or any information. Then real-time operations. In memory database are well suited for applications requiring real-time data management, such as telecommunication, banking, and gaming. Then data availability. If we store our data permanently in a database, it is our job, we check it is available as and when it is required or not. Data in an memory is always readily available, eliminating the need to wait for disk access, which can be a significant advantages in latency sensitive applications. Then persistence. While in memory database or for rapid access, they also require mesh mechanism for data persistence, such as shaping changes to disk or using techniques like replication to prevent data loss in case of power outage or system failure. Then use cases. In memory databases are frequently used in applications that are require microsecond response time or handle large spikes in traffic, such as gaming, leaderboard, station stores, and real-time data analytics. For examples, in-memory database include Redis, Apache, Ignite, and VoltDB. So these are the softwares we can use in the case of use cases. Then graph database. A graph database is a specialized database designed for storing and querying data with complex relationships. Features of graph database, nodes and relationship, property graph, schema flexibility, efficient relationship querying. So nodes and relations. Data is represented as nodes, entities, and edges relationships between them, allowing for efficient traversal and verifying of connected data. So all the nodes having some information and that information are linked to each other with the main node called as root. Then property graph, a common type of graph database that allows nodes and relationships to have properties or attributes associated with them. Then schema flexibility. Graph databases often have flexible or evolving schemas, allowing for a easy adaptation to changing data requirements. Then efficient relationship querying. Relationships are stored directly in the database, enabling fast verifying of connected data. Then use cases of graph database. These are social network, knowledge graph, recommendation system, fraud detection, cyber security. Social network, representing connection between users and groups. Then knowledge graph, building and querying large dataset with interconnected information. Recommendation system, identifying similar items or users based on relationship. Then fraud detection, analyzing patterns and connections in financial transactions. Then cyber security, identifying malicious connection in network database. The various examples of global database or graph database here, we discuss about it. A popular commercial available graph database with a focus on performance and scalability. Similarly, dgraph, a highly performant and scheduled distributed graph database. Then we discuss about the open source database. What is that open source database? Open source database are database system with freely available source code, enabling public use, modification, and distribution. Means the open source database are available to public, and public can be modified, distributed as per the Now, the features and benefits. Open source nature. The core code is publicly available, fostering collaboration and customization. Then cost effective. Often source databases are typically free to use, eliminating licensing fees associated with proprietorship solution. Then community support. A large user base provides ongoing support, bugs, fixes, and future requests. Then flexibility and adaptability. The open source nature allows you developers to customize and extend the database to fit specific requirement. Then wide range of applications. So what are the application of open source database we discuss in this slide? Open source database support various data models, including relational, NoSQL documents, key values of graph are in memory, creating to diverse application needs. So there are different examples we mentioned here. The first one is a relational database, that is the MySQL. So we consider here MySQL, PostgreSQL, MariaDB, NoSQL database, MongoDB, Apache, and Couchbase server. In memory database, Redis, graph database, Neo4j, and time series database is the QuestDB. When to use open source database? Cost conscious environments. When the budgetary constraints are a concern, then customization needs. When a tailored solution is required or when adapting the database to specific needs is essential. Then community driven development. When leveraging a large community of users and contributors for support and enhancement is advantageous. Open standards. When open standards are interoperability are desired. So these are the open source database. Then database as service. Database as a service is a cloud-based service that provides to access to database software and functionality without the need to manage the underlying infrastructure. So what happened? Database as services represented in the abbreviated form, that is a DBAS, database as services. As we know, software as services, infrastructure as services. Similarly, DBAS, database as a services. And the main characteristics of DBAS, database as a service, the cloud provider takes care of all the complexities of running a database, including infrastructure, management, software installation, and maintenance tasks. Then cloud-based. DBMS or database as a service are offered through cloud platform, allowing user to access database remotely via the internet. Then scalability and flexibility. DBAAS solutions are designed to be scalable, allowing users to adjust the database resources based on their needs. Then reduce overhead. DBAS database as a service eliminates the need for users to manage hardware, software, and other infrastructure related tasks, reducing operational cost and freeing up resources. And cost effectiveness. Database as a service often operate on a pay as you go and subscription based model, allowing user to pay only the resources they consume. Simplified database management system. Simplified database management system means DBAAS database as a service reduces the burden of database administrator and maintenance, allowing developer and business user to focus on their core task. Then DBR services allows for faster development and scaling of database, enabling businesses to respond quickly to changing the need. Then cost saving. DB and services can reduce IT cost by eliminating the need for the specialized staff, hardware, and software. So if you implement the database in the front end and back end in the company, it reduces the cost. Then improve security and compliance. Cloud providers invest heavily in security infrastructure and compliance measures which can benefit users of DBMS as services. Because cloud database means we are not knowing who are the users to access the information. Hence, it is required to improve the security and the compliance mechanism. Then disaster recovery and high availability. DB as services, solutions often offer features like disaster recovery, high availability, ensuring that database can remain accessible even in the event of failure. Oracle Cloud Infrastructure is the one example of DBAS database as a service provider. Oracle Cloud Infrastructure, Amazon Relational Database Service, Microsoft Azure SQL Database, Google Cloud, and MongoDB Atlas. These are the softwares basically used in the database as services. Then we discuss about data mining. What is actually data mining? Before we discuss about the data mining, it is required to know the database. Database, as we discussed earlier, database means it store the data and information in a systematic manner. In general, it is called as a row and column as well. Rows are the records and columns are the fields. And database is created on the basis of the models It may be tree model, network model, relational model, object-oriented model, and ER model. So database store the data permanently. If large amount of data are stored in an organization, it's called as a data warehouse. In data warehouse, we use ETL, extract, transform, load techniques to store different types of data in a common format. And data warehouse store the past data and the present data. So data mining is a technique, is a tool, is a mechanism. Just like your Google search engine, it extracts the meaningful information from the data warehouse for the analysis purpose as has been required by the managers at top level levels. Hence, data mining is a process of sorting through large data sets to identify patterns and relationships that can help solve business problems through data analysis. Data mining techniques and tools help enterprises to predict future trends and make more informed business decisions. Data mining is the process of extracting knowledge or insights from large amounts of data using various statistical and computational techniques. The data can be structured or semi-structured or unstructured and can be stored in various forms such as databases, data warehouse, and data lakes. Data mining has a wide range of application across various industries, including marketing, finance, healthcare. Data mining can be used to identify customer segmentation and target marketing campaigns while in healthcare. It can be used to identify risk factor for disease and develop personalized treatment plans. So data mining is a search engine. It is a tool used in the business organization to retrieve different types of data for analysis purposes. In a business organization, we retrieve the sales data and predict on the basis of this sales data, we can predict how to improve the sales in the next term. It is used in the healthcare to identify a disease and what are the medicines we provide to the customers for the curable conditions. So, in customer relationship management, we use data mining techniques to retrieve the data, to identify the potential customer, because customers are the brand ambassador for the organization. If we find the potential customer, we provide all services to the potential customer and try to retain the same customer for a long period of time to make the business profit. So data mining plays an important role in every organization for data analysis purposes. The scope of data mining. Data mining derives its name from the similarities between searching for valuable business information in a large database. For example, finding linked products in gigabytes of stored scanner data and mining a mountain for a vein of valuable ore. Automated prediction of trends and behavior. As I have explained, data mining automates the process of finding predictive information in large database. Predictive information is the future trend. Questions that traditionally required extensive hands-on analysis can now be answered directly from the data quickly. A typical example of a predictive problem is targeted marketing. Data mining uses data on the past promotional mailings to identify the target most likely to maximize the return on investment in future mailing. Other predictive problems include forecasting and other forms of default and identifying segments of a population likely to respond similarly to given events. Automated discovery of previously unknown pattern. Data mining tools sweep through databases and identify previously hidden pattern in one step. And the pattern discovers on the basis of the sales data, and on the basis of that pattern we can focus how to increase our sales. I've already discussed. Task of data mining. Data mining involves six common classes of task: anomaly detection, that is the identification of unusual data records that might be interesting, or data errors that requires further investigation. Association rules learning, that is searches of for relationship between variables. For example, a supermarket might gather data on customer purchasing habits. That I have explained. The supermarket focus on the potential customer always. That's why it is the association rules of learning is required. Using association rule of learning, the supermarkets can determine which products are frequently brought together, and we maintain the stock. Use this information for making purpose, marketing purpose. This is sometimes referred to as market basket analysis. Then clustering. Clustering is the task of discovering groups and structures in the data that are in some way or another similar without using known structure in the data. Then classification is the task of generalizing known structure to apply new data. For example, an email program might attempt to classify an email as legitimate or as spam. Regression attempts to find a function which models the data with the least error. Summarization provides a more compact representation of data set, including visualization and report generation. Then, data mining system can be classified according to the following criteria: database technology, statistics, machine learning, information science, visualization, and other disciplines. Classification according to kind of database minded, classification according to kind of knowledge minded, classification according to kinds of techniques utilization, classification according to application adopted. These are the four classification criteria. Now we discuss about classification according to the kind of database minded or mind. We can classify the data mining system according to kind of database mind. Database system can be classified according to different criteria such as data models, types of data, and the data mining system can be classified accordingly. For example, if we classify the database according to data model, that we may have a relational, transactional, and object relational or data warehousing mining system. Classification according to kind of knowledge minded, we can classify the data mining system according to kind of knowledge minded. It is means data mining system are classified on the basis of functionalities such as characterization, discrimination, association, correlation analysis, classification, and prediction, clustering, outlier analysis, evolution analysis. Similarly, classification according to kinds of techniques utilized. We can classify the data mining system according to the kind of techniques used. We can describe these techniques according to degree of user interaction involved or the methods of analysis employed. Classification according to application adoption. We can classify the data mining system according to the application adopted. These applications are as follows: finance, telecommunication, DNA, stock markets, email, etc. Then knowledge discovery. Some people treat data mining same as knowledge discovery, while some people view data mining essential step in process of knowledge discovery. Here is a list of steps involved in knowledge discovery process. And the steps are data cleaning, data integration, data selection, data transformation, data mining, pattern evaluation, and knowledge presentation. So data cleaning in this step, it is the first step. In this step, the noise and inconsistent data is removed. So unnecessary data are cleaned up. Data integration. In this step, multiple data sources are combined. Data selection. In this step, relevant to the analysis task are retrieved from the database. Data transformation. In this step, data are transformed or consolidated into forms appropriate for mining. Data mining. In this step, intelligent methods are applied. Pattern evaluation. In this step, data patterns are evaluated. Knowledge presentation. In this step, knowledge is represented. Then major issues in data mining. Mining different kinds of knowledge in database. Then interactive mining of knowledge at multiple levels of abstractions. Incorporation of background knowledge. Then data mining query language and ad hoc data mining. Presentation and visualization of data mining results. Handling noisy or incomplete data. Then pattern evaluation. These are the major issues. Then efficiently and scalability of data mining algorithm, parallel, distributed and incremental mining algorithm. In data mining, basically we used different types of algorithms which are programmed to retrieve the important information from the data warehouse for the generation of patterns. These algorithms divided the data into partitions, which is further processed parallel. Then the results from the partitions is merged, and the incremental algorithms updates databases without having mined the data again from scratch. So these are the major issues during the data mining process. So in the today's class, we know what is actually the DBMS, what is the scope of DBMS, and what is actually our data mining, and how the data mining is implemented, and what are the challenges to implement the data mining,